For this video, we're going to talk about congruent triangles and determining when triangles are congruent. We're going to talk about the definition of congruent, how to prove congruency, and the 3 cases for solving if a triangle is congruent. So the definition that we've always been told is same size, same shape. What this means is that the triangles have common length of sides and common angle. So they have the same size and the same shape. So we look at these 2 triangles. They've been identified, so these angles, we know because of the markings, are equal. These angles are equal. These angles are equal. We know because it's been labeled that, these 2 sides are the same length, so are these, and so are these. They can also be labeled by tick. So if there was a 1 tick here and a 1 tick here, we would know that these 2 sides are the same length. If there was 2 ticks here and 2 ticks here, same with those. So when we're proving congruency, we have to list common sides and angles. And you do that by, side AC is equal to side DF. So you're identifying the 2 equal sides on the 2 triangles to demonstrate that they're congruent. And also with the angle. So angle ABC is equal to angle DEF. So we know that that center letter identifies the angle. So we're talking about this angle here, and they are congruent. And then we have a summary statement at the end. Therefore, triangle ABC is congruent to triangle DEF. And the symbol for congruent is an equal sign with a tilde over top, a little wavy line. So that's our definition and how we prove congruency. Now, we can, instead of writing out all of the common sides and all of the common angles, there are some rules that we can use. They call them cases, where we can explain how we know that they're congruent with a short form. So we're going to go through those 3 cases now. The first is side, side, side. So if we get 2 triangles, and these ones have they have different orientation. So the one looks like it's flipped over here. We know that these 2 sides are the same because they're marked. We know that these 2 sides are equal because they're marked. We know that these 2 sides are equal because they are marked. So because all of the sides are equal, they have to be congruent. That's the side, side, side rule. So I can list side AC is equal to side DF, AB is equal to DE, BC is equal to FE. Therefore, triangle ABC is congruent to triangle DEF because of the SSS rule, or the side, side, side rule. I didn't put a triangle there. There should be a triangle there. So that's the side, side, side rule. The next is, case number 2 is side, angle, side, or the SAS rule. So we have 2 triangles, and again, their orientation is different. And this is how it's going to look in an assessment. They're going to look different, and you have to use the clues that are given to decide whether or not they're congruent. We know that we have 2 common sides. One is labeled here, and one is labeled here. We also can see that we have a common angle because it's identified with these little angle marks here. The side, angle, side rule is if you have 2 sides that are common, which we do, and you have a common angle that is in between those 2 sides, then your 2 triangles are congruent. So we have 1 common angle here, 1 common angle here, and 2 common sides and a common angle that is between the 2 common sides. Our triangles are congruent. And remember, you always show your work. So side XY is equal to PQ, right? Side ZY is equal to RQ, and angle RQP is equal to angle XYZ. So therefore, triangle XYZ is congruent to, again I forgot that triangle mark, PQR, because of the SAS rule, or the side, angle, side rule. So you're stating why you found your answer, how you know that your answer is correct, what rule you used. And the last case is angle, side, angle. So we have our 2 triangles, And we know that we have this angle is the same, and these two angles are the same. We know that these sides are the same. So the rule is if you have two common angles, two pairs of common angles, which we do, and one common side, which is between or connects those two angles, which it does, then your triangles are congruent. And you list it. Angle BAC, and angle MLN are equal. Angles ABC and angles LMN, right, because we're measuring here, are equal. And side AB is equal to side LM. So again, if you have two pairs of common angles and one pair of common sides, and the common side is in between the angles or connects the two shared angles, then your triangles are congruent. Therefore, triangle ABC is equal to triangle LMN. And what needs to go here? I need to show how I know. I need to show what rule I use. So it's angle, side, angle. It would be ASA.